Hello and welcome back. Okay, so in this video, we are going to talk about the properties of the expectations. Okay, so this one I hope that they will help simplify some calculations of the expectations so that we don't have to find integrate x, fx every time. Okay, every time you do the expectations. Okay, so the first one, very easy. Okay. If y is equal to ax plus b, where a, b finite constant, ey is this one. The intuition is simple, okay? Because we know that e of y is gonna be what? Integrate ax plus b of the fx dx. And here, notice that we are using the law of Lotus, okay? The law of the unconscious statistician, okay? And then we split, okay? We split into A, integrate x, fx dx, plus B, integrate fx dx. This one is equal to 1, okay? This one is equal to e of x. So the final answer is going to be A times e of x plus B. Okay, the intuition is very simple, okay, but very useful. Okay, next. Inequalities. If there exists a constant such that probability of x greater than or equal to a is 1, then e of x greater than or equal to a. If there exists a constant besides and this one, so ex is greater than or equal to b. So I am going to show you the first one, okay, but the second one, the intuition is very similar, okay. So what is e of x? Of x is what? Is integrate, let's say x such that, okay, something like this is better. 0 to a. Let's say it is continuous, okay? X fx dx. And then plus a infinity and minus infinity. X fx dx. Since we know that probability of x greater than or equal to a is equal to 1, that is fx here is going to be 0 because it is not in the support, right? And then for that one, equal to integrate a infinity x fx and the dx. But we know that fx is positive for sure, positive or 0. So this one we can sure say that it's gonna be greater than or equal to what? Because x is greater than or equal to a, right? So we could write something like this. That is but this one we know that it is equal to 1, right? That is this one is equal to a and done. Okay, the intuition is simple here. So let's go to the third property. Okay, the third property is the probability with certainty. Suppose that ex is equal to a and either this one or this one too. Let's say suppose this one for the easy of the proof. Okay, so we have these two conditions and we have to show that this one must be true. Okay. Okay. because this one is equal to the probability of x equal to a plus probability that x is greater than a is equal to 1. If this is equal to 1, what does it mean? It means that probability that x greater than a is gonna be 0, right? How do you prove this one? Okay, let's see. Suppose that, yes, suppose that this one is greater than 0, strictly greater than 0. What happens? Okay, e of x is gonna be what? Because subplot is this one, right? It's gonna be a infinity. Okay, x fx and dx. Okay. Okay, let's say the sum. I think the sum is easier to think about. Okay, the sum. Okay, I think it's easier to think about the sum. So, and we have to change the notation to write the problem. But the concept is the same, okay? It cannot be the continuous actually because we have this one as the binding condition. So it must be discrete, okay? It must be discrete by nature. So this one is gonna be a p of x equal to a plus what? Plus sigma x greater than a x p of x and no dx, right? No dx. And this one greater than a and sum. In other words, e of x greater than what? A, because we have this one, right, as a common term. X equal to a plus this one. However, this one is equal to 1, right? So that means EX is greater than A. That contradicts, right? That contradicts with the initial assumption. Okay. Next, sum of the expectation. Okay. So this one is a little bit simple because we have something like this. E of x1 up to xn, right? So it's gonna be, so let's say two terms, okay? And we use it by induction. So let's prove the easy one. x1 plus x2 is equal to e x1 plus e x2. So how do you prove this one? Okay. So let's say integrate two times, okay? Integrate two times. x1 plus x2. And we then f x1, x2, dx1 and dx2. And then what happens? Split, right? Split the integration x1 f x1 x2 dx1 dx2 plus integrate two times x2 f x1 x2 dx1 and dx2. Okay, what should we do next? Let's switch the integration. Let's switch this one. Let's switch this one. dx2 dx1. What happens? We can pull x1 out. We can put the x1 out. And similarly, because the x1 is inside, right? We can pull x2 out. And this one is the concept of what? Flattening out. Flattening out. After flattening out, what should we get? Integrate x1 form joint. We get the marginal, okay? Let's say g of x1, dx1, and integrate x2, h of x2, and d of x2. This one corresponds to e of x1, right? And this one corresponds to e of x2, okay? And that's the proof. And the corollary is very similar, okay? The corollary, let's say this one, very similar. But one thing to notice here is that we do not require independence at all. Okay, some people believe that, oh, x1 here must be independent in order to take the sum of expectation or variance of anything. No, look at the proof. No requirement of independence. Okay, so take a note here that do not need to be independent. Oops, do not need to be independent. Do not need to be independent. Okay, so next, Jensen inequality. Okay, so let's define. It's about the convex and the concave function. Okay, if you study some of the course like the mathematical economics, I think that you have heard some of these terms. Okay, let's review. So if convex, okay, let's think about the picture. What does it mean to be convex? Convex is on curve like this, right? So it's x1 is x2. Then you have to take the average, okay, the average. So the average of x1, x2 and take the function. It's gonna be, okay, so let's define x alpha x1 plus 1 minus alpha x2. So fx is gonna be something like this, right? Fx1, x2. However, if we take the average of the x first and then take the function, it's gonna be somewhere here. Oh, no, sorry. So this one is actually fx. But this one is gonna be alpha fx1 plus 1 minus alpha fx2. So it's similar by the picture here. Okay? So let G be the convex function and let X be the random vector with the finite mean. So this one. So this one is very similar to the above one. Okay. So this one actually has the proof, but I do not think that the proof is constructive enough. So I'm going to draw the picture instead. Okay. So let's say, no, I do not want this kind of line. Okay. Okay. and then is x, and then g of x. Let's say it's concave with convex. It's gonna be something like this. So you take any 2 points, okay? Any 2 points. If you assign the probability distribution, okay? So the S is gonna be something along this line. Along this line. Suppose that there are 2 points, okay? X1, X2. So this one, suppose that it's gonna be EX, E of X, okay? So what does this point correspond to? Because E of X, let's say, must be, if we take in 2 points, for example, okay? So E of X is gonna be somewhere in the middle. So this point is gonna be G of EX. G of EX. How about the above one? The above one is that we have to what? We have to take average between what? Between G, right? G of X1 and G of X2. By taking the average, it's gonna be somewhere at this point. So rather than G of EX, it's gonna be what? It's gonna be the weighted average of these two, right? It's gonna be the weighted average of these two. Or the other words, it's gonna be E of GX. That is, E of GX is larger than or equal to G of EX. And that is the picture intuition, okay? So I hope that you remember by the picture. Because I survived because this kind of intuition, okay? 6, independent random variables. That's when it requires independent. The sum does not, but the product require, okay? The product require. Let's say 2 random variables, let's say. So let's say 2 random variable case is going to be E of x1, x2 is equal to E of x1 times E of x2. But this is valid only what? Only in the case of the independent random variables only. So how do we prove it? From the left hand side first, okay? x1, x2, f x1, x2, dx1, dx2. Straight from the definition. And then, how do you copy this? Because f is independent. What does it mean? What does it mean? It means that we can split the f into g x1 and h of x2, right? Because the inner loop we have x1, so we are going to separate, okay, x2 hx2 and indicate x1 gx1 dx1. Since this one doesn't require x2 also, so can write the x2 here. It is actually what? It is actually the 2 terms here. 2 terms here. Okay. And what does the first term represent? The first term represents EX2, right? The second term represents EX1. And done. This one is equal to this one. Okay. So remember, the sum doesn't require independence. but the product requires the independence. This three counts. For this one, I'm going to prove by the picture, okay? But the strong condition is that X a number that take only value 0, 1, 2, and so on. What does this mean? Okay. So what does E of X mean? E of X is going to be what? It's going to be consist of 0, we do not count, okay? So it's going to be F of 1 plus what? 2 F2 times 3 F3, so on and so forth. But this one is not clear yet, okay? So I'm going to write something like this. This sum is equal to this sum. Will you believe it or not? So this F1, F2, F2, F3, 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 and so on. And we have this also. This one, the sum is equal to this one. This triangle sum, infinite triangle sum. Why do we have to rearrange something like this? Because by summing by the rows, okay? Above one is summing by the rows. Row 1 is F1. Row 2 is 2F2. Row 3 is 3F3, right? But can we sum by columns? Yes, because we could get exactly the same answer. What does the first column represent? Probability that X greater than or equal to 1. What does the second column represent? Probability that X greater than or equal to 2. Third column represent what? Probability that X greater than or equal to 3. Sum, and so on and so forth. It is the same sum, right? Because we sum from the same triangle. Just like we sum for row or column. Okay? And this one generalized to this one also. Because F of X is probability that X greater than or equal to X. 1 minus is going to be that. Oh, sorry, it's going to be less than, right? Less than. It is extremely similar, except that not equal, because equal or not equal is the same with the CDF, with the continuous. Okay. Okay. The first example, go through it quickly. Suppose that a person types n letters, type n address, and then place at each letter. Let x be the number of letters that placed correctly. We find the mean of x. So let's define x is the sum of xi, x1, x2, x3, x4. That is, xi equal to 1 if I letter is placed correctly. So I'm going to tell that this problem, the straightforward approach is very difficult. But if you, let's say, this integrate, because the x, we know that it's equal to x1 plus x2 plus x3 and plus so on, and plus xn. So E of x is equal to E of xi, sum I up until n. Just find EXI and done, because they are all symmetric. Okay. Probability of xi equal to 1 is 1 over n. I equal to so 1 minus 1 is 1 over n. So on average, we pass them together, we get 1. Doesn't matter how many envelopes are there, but on average, we get 1 that passed correctly. Okay. So let's go to the next question. The next question, we talk about this one. Okay. So if they are independent, we can integrate, disintegrate from this one to this one. Okay. And the rest of them are very simple. Okay. Go to the third example. Suppose that a person repeatedly tries to perform a certain task and with success. Probability of success of E given trial is P and of that independent. So we're going to find E of X. First note that PR probability that X greater than or equal to 1 is 1. So they must do the first trial at least. Okay. And the second one, probability that H greater than or equal to N. So that means at least N trials. What does it mean at least N trials? That means trial number 1, number 2, up until N-1 fail. What is this probability? It's going to be this one, right? And then the expectation is going to be the sum of this one. It's going to be plus dot dot, not only this term. And by the formula of the geometric sum, we get that. Okay? And that's the end of the explanation. So in the next lesson, we are going to talk the variances, okay, about the variances. Okay, so see you next time.